Thank you so much for having me here today. It's wonderful to be here with all of you. Today, I'm going to talk about the GDELT project and this vision that I presented in 2012 at the IIPC conference of this idea of web archives as not just passive archives of content, but as real-time research platforms that, as they're gathering information about the world, allows us to actually begin to understand it. So this is sort of the vision. This is a real image, by the way, actually, of a NOAA Science Hemisphere. And this is really this vision, essentially, of scooping up the world's information and processing it in real time to be able to understand what's happening across planet Earth. And the GDELT project focuses on news material specifically. So while different web archives have different focal points, GDELT really focuses on global news material across the entire planet, all countries, currently 152 languages. But that includes both text and imagery, as we'll get to in a moment, which is a really powerful addition there. So of course, GDELT starts with news, and its goal is to really reach across the entire planet, to reach across every corner of Earth that it can, essentially. Now, an image like this is very powerful. This is actually where GDELT got, I think this is about a 3-year period of all the locations on Earth that GDELT collected news information about. But what becomes really powerful is when we look at this image. Color coding it by the primary language of each of those locations. And this is something that's particularly powerful, is that historically web archives, especially here in the US and Europe, have been less focused on the entire planet as a whole. And GDELT's focus really is the entire planet, to really reach locally across everywhere it can. So to this degree, GDELT monitors 152 languages today, and it live machine translates absolutely everything it monitors in 65 of those languages. So this means that we're able to reach across the entire planet as things are happening, as news coverage is generated across the world. We process that in the native language if we have that capability, or we also translate into English to be able to process it through this much richer array of natural language tools, since of course so many of these natural language tools exist only for English. Now, what makes this so unique is this ability to combine real-time and retrospective. So you can imagine, traditional web archives, you're streaming in all of this data from across the planet. You've got these crawlers, they're crawling the material that you're interested in, and then that goes into, this cold archive, probably into large work files, stored into a disk array or cold archive somewhere, and that's kind of the end of it. And perhaps, some web archives allow some degree of retrospective analysis where, researchers are having to dig in the work files or having to go into all this complex analysis. The goal of GDELT really is to say, what if we turn that into its head? And it's a research-first platform where we're crawling the web, and as that material is coming in, we're running it through this rich array of machine learning algorithms to catalog, to essentially, as we find a news article on the web, take that, analyze it through so many different algorithms, and produce these real-time data streams that are cataloging what's happening around the world, with the side effect that we also then deposit those web pages into platforms like the Internet Archive. So it kind of combines this real-time and retrospective. And what can we do with this? Well, many things. GDELT's used to map world events in real time, to look beyond the physical events to the narrative. So, take something like climate change. What we're particularly interested in is less the physical activities that are occurring, because there's other sources to monitor that. But what are the narratives? How is that being constructed in the media around the world? But then also look at framing and emotions. How is the news essentially framing things around the world? And the end result is a huge number of data sets. And what you're seeing on the screen here is just a fraction of the data sets that GDELT generates. And I'm going to dig into just a couple of those today that are particularly relevant to the web archives community. So again, this idea that GDELT is really this research-first web archive. We don't just crawl the web and archive it. We process it in real time and make these high-level analyses available to researchers. This includes neural and statistical representation, specifically though with petascale tooling. So this isn't just where you're storing, a lot of the work that's being done in web archives is, people build toolkits that can, load work files in and operate on a small to low medium-sized cluster and do some basic analyses. The idea here is, what happens if we sort of make the scalability infinite? If you have a question and all of a sudden you can analyze it using hundreds of thousands of processors to analyze that. So in particular, some of the examples I'll give with GDELT, it's very common to build terascale graph to say, for example, take all the co-mentions of different entities across billions and billions of articles and construct it to a terascale graph that allows me to really understand the fine level changes and how that's occurring over time. Petascale geographic mapping, be able to combine the retrospective with these representations. So GDELT exists entirely in Google Cloud Platform. It uses primarily Compute Engine and the different pieces there, all the different machine learning APIs, and then tools like BigQuery that allow you to really ask the question. Because you imagine the end result of this is just enormous, enormous trillions and trillions upon data points. So how do you actually make sense of that? And that's where things like BigQuery come in that I'll talk to in a moment. So I should add too that one of the things, traditional web archives, they just, crawl. One of the things for GDELT, because it's focused on news material and specifically the types of questions content analysts want to analyze, we have two specific types of crawling that are very specific to the kind of content analysis. So one is a front page graph. So since March of 2018, we crawl 50,000 news homepages every hour in the hour, precise time guarantees. So far, it's generated about 200 billion links in page positions. So this allows you essentially to ask, take the front page of the Washington Post every hour in the hour. How often is that, of that have climate change related coverage be linked to from the homepage, for example? But also the difference graph. So stealth editing is really, really critical. And traditional web archives, you get change detection there, but it's not precise. So here we recrawl after 24 hours and after 1 week precisely, and we have, we can generate all kinds of different things. We essentially do a diff of each of the actual, just the content of the article. So we can tell, for example, what's being changed, how often these pages are being deleted. And these are, because of these time guarantees, we're able to do really precise types of content analysis. And I should also add that everything that we crawl from across the web, we send every one of those URLs to the Internet Archive's Wayback Machine as part of the No More 404 program. As of November 2017, that was 5.4 billion URLs, 221 terabytes that have been sent over. So again, depositing this content to major web archives to allow that material to be archived. Now, in terms of real-time analysis, we do so many different things. So every one of these news articles, when we find a news-related web page on the web, what do we do with it? So one is the global knowledge graph. So the live metadata index, 152 languages. And essentially, we take each of these articles and we run it through a whole bunch of different machine learning algorithms. An interesting story, actually, is that Blue Dot Global, they're actually a biosurveillance company up in Canada, actually sent one of the very first external alerts about COVID-19 using our data. Because again, we're crawling this material across the web in real time. In late December, we started encountering articles in the Chinese language press, specifically in the Wuhan province press, that reported a viral pneumonia a SARS-like viral pneumonia of unknown origin. And so again, that goes out in terms of this real-time metadata index that we're producing over global material. And in turn, they have machine learning models that process that material and say, hey, this is actually the characteristics of this that are being reported, of this disease that are being reported in the news media are actually strongly suggestive of something that's extremely dangerous. And so then we have the quotations graph. So oftentimes you want to know who's saying what. And so, for example, you want to be able to say, not, give me everything about COVID, but what are the actual quoted statements being made by public health authorities, for example? So being able to track that. The global geographic graph, so we go through each article, we extract out any geographic reference. So if it talks about, for example, Paris, we'll figure out if that's Paris, Illinois, or Paris, France. We'll disambiguate that, give you centroid longitude, latitude, and actually give you the brief snippet that occurred around that location. So you can actually map things in real time and be able to do this across those languages. So the geographic graph is 65 languages, but our core engine, our API actually supports all 65 languages. We have an entity graph, so we actually use Google's natural language API. We analyze 11 languages to date through their API. And this allows us, for example, to, in 11 different languages, natively extract out the entities and understand grammatically, the dependency parses, how all those entities interrelate, and run those through things like Inference API that allows us to actually begin to understand the high-level patterns, like, for example, anomalies in co-occurrences or relationships between entities. We also generate 152 language engrams. We have 100 billion token dependency and part of speech data set. These massive linguistic data sets that give you, for example, so you can say, give me the word dog. Tell me how often it appears in a verb context in a particular dependency role in a sentence over global news media, and how is that evolving? How is that, particularly, for example, in English, how is that varying by different dialects across the world? We have a relationship graph. This is actually very experimental right now. We're trying to codify claims and relationships in real time so you can autonomously detect emerging contested narratives across the world. We have a variety of different APIs. So these are full text search APIs that allow you, for example, to keyword search those machine translations in real time and be able, for example, to get back So say, for example, give me all the articles that discuss masking, for example, around the world in the COVID-19 context, and be able to get that back in real time, second by second. As we find an article, as one of our crawlers comes across an article, we send that. So you can imagine, as a crawler comes across an article, that URL is being sent immediately over to the Internet Archive for indexing. We translate it if necessary, and then both the native language and the translation then goes through all these different data sets that we produce on top of that. But of course, so much of the web, of course, the visual world is so important today. So all that imagery that's in the web, historically, that's kind of been a set aside. People haven't done that much with it. We've actually monitored about 500 million images since 2016. We've actually run through Google's Cloud Vision. So every news article we come across, we look at any imagery that's in the core of that article, and we actually analyze that through Google's Cloud Vision API and actually analyze, so that's the labels, it's OCRs, geography, and the EXIF metadata. We also do a reverse image search across the open web, so we can tell you, here's an image right here on this particular page. It's labeled as a protest in Iran right now, 10 minutes ago. But we can tell you that reality, a reverse image search tells us this image has actually been around for 4 years, and it's traditionally captioned when it appears elsewhere in the web as Saudi Arabia. So that can give us some really interesting indications, for example, for verification questions. We can look at imagery. So it does not do facial recognition, but using the captioning, we can say, find this imagery that's been captioned as Donald Trump. So you can do some really interesting visual representation. We can do real-time verification, things like natural disaster imagery. We can look in the background and estimate things like ground pollution and air pollution. We can do geographic representations. We can also, of course, in collaboration with the Internet Archive's Television News Archive, we're also non-consumptively analyzing television news. Now, again, that's not strictly a web archive, but again, giving you this whole idea between text and imagery and spoken word and video, the full range of different types of analyses. So you can do things like find television imagery or find web imagery of bookcases where that's in the background. We can, of course, both web imagery and television is OCR'd in, I think, 300 plus languages now. So we can do this rich search and detection. So you can use, for example, OCR in television to track, for example, the CNN's COVID dashboard. You can use, because again, all this data is sitting in platforms like BigQuery, you can write one regular expression and say, find me all the doctors on television, get me their names. So look for the word doctor in their title and find the name that follows that. Make me a daily histogram by station to find out who's telling the story on television. Of course, you could do the same for offline imagery. We can compare visual similarity. We can also do verification. So here's the tie between television and the web. Here's an image. This is a short clip that appeared on CNN about COVID. CNN didn't describe what this is. They just show a clip that you see here. What we're able to do then is take that still frame, use Google's Cloud Vision, do a reverse image search across the open web, and then immediately within, literally a fraction of a second, we're able to take this broadcast and instantly tell us that this is actually nurses in Durban. We're able to tie into a complete rich description of what was in that broadcast. And of course, we can actually we have another example where we actually took an entire broadcast and did this second by second and actually completely contextualize every clip that was in that broadcast. So again, this ability that, once we have this type of data, to tie different modalities together. And so again, I've covered a huge amount of ground really quickly here, but this overall idea of, we think about web archives as crawling the web, bringing material in, archiving it in especially file formats like WARC, and then just acting as cold archives, perhaps with the ability of a user to come along and request a version of a particular version of a particular page at a particular instance in time. Most of the research, though, is very small scale. It's sampled, and most importantly, it's retroactive. It's after the fact. Let's go back to this archive. Traditionally, like how a print archive is traditionally accessed. Instead, GDELT is really this vision of real-time analysis, where essentially, as this material is coming in, you can imagine a traditional web archive that goes straight to disk. With GDELT, instead, it comes in and it gets piped off to archives at the Internet Archive for permanent archival. But the real focus is to produce all this real-time rich annotations over the web at large, essentially a real-time rich metadata, kind of like the vision of the semantic web, but actually actualized, to be able to analyze the world in real time and be able to use this to study all kinds of different things, from disease outbreaks to conflict across the world, to contested narratives, to misinformation. So again, I've covered a tremendous amount of information in just a short amount of time, and this is just a fraction actually of the overall scope of GDELT, but I wanted to give you an idea of just some of the core data sets there. And again, all this is open data. You can go to the gdeltproject.org and download all this data today. Thank you so much for having me. It's been great to be here.